Now we're going to make things personal. In talking about volcanism, we need to consider its effects on human activity, human society, economics, climate, things that are near and dear to our hearts. So we have to discuss volcanic hazards, the direct effect, the direct danger posed by volcanic activity. These include lahars. Lahar is a mud flow, a mixture of usually hot ash with glacial meltwater. This mixture of hot ash and meltwater produces a thick, cement-like, but very hot, very fast-moving, viscous morass that pours over people, pours over buildings, vehicles, destroys everything in its path. Flank collapses when the side of a volcano gives way. That provides another conduit for explosive gases and magma chambers to evacuate from the side of a volcano, as we saw with Mount St. Helens. Then we have a caldera collapse. Once the magma chamber is evacuated, the entire mountain can collapse into itself. Crater Lake, which erupted as Mount Mazama almost 9,000 years ago, was observed by Native Americans at the time. They saw the mountain rise, explode, and collapse. And it's reported in their oral tradition. Eruption clouds, something we'll talk about for the next few minutes. These are particularly dangerous, particularly fast-moving, and devastating. Mantle plume hypothesis allows us to predict eruptions, the location, and give or take 50 to 100,000 years, the timing of an eruption. There are ways that we can control eruptions. Some less stable people have suggested using nuclear weapons to control volcanic eruptions. Probably a totally unsuccessful idea, but we have been successful in the past in controlling lava flows. Iceland was famous in the 60s for pumping seawater from fireboats onto a lava flow that was threatening to close off an important bay, an important port. And in Hawaii, the same technique is used to direct lava flows away from subdivisions. Volcanoes provide us with abundant natural resources. We saw, in the case of Indonesia, the recovery of elemental sulfur. That's not a particularly safe or viable long-term employment opportunity. However, volcanic ash produces very, very rich soil. This is why people tend to accumulate or populate areas around volcanoes, not because they're attracted to the volcano itself, but they're attracted to the good soil. Industrial materials, like that elemental sulfur, are recovered. Ores can be formed in volcanoes, either as a result of the eruption itself, or more likely later on through infilling of pores with valuable metals. Volcanoes can provide us with a source of heat energy, geothermal energy. When we look at the history of fatalities related to eruptions, and this is a very short, very brief history here, we'll start with the 1500s. A volcano known as Kalut erupted violently, killing about 10,000 people. 500 years ago, we don't have good population data, particularly for this part of the world, so that's a pretty loose guess. Laki comes along in 1783, and over a period of 8 months, erupts so much gas and so much material, so much ash, that it cools the global climate and kills, actually poisons livestock in Iceland, in Scotland, in northernmost England, and probably continental Europe as well. So starting with Kalut, located right here in Indonesia, we can see that today this sulfuric acid pool in the crater indicates that the volcano is active, remains active. It will go off again. And as is typical of many volcanoes, there are numerous spellings. These are all accepted by people in one place or another around the world. Unzen, located in southern Japan, is another dangerous volcano. This erupted in 1792, just after the Laki eruption, just after the French Revolution. It generated a tsunami that killed approximately 15,000 people. When we look at Indonesia, we can see that this is really the place to be. If you want volcanic action, you want gases, you want ash, you want explosions, phreatic eruptions, you want global climate devastation, this is the part of the world you want to check out. Tambora, one of the more famous eruptions, took place as a series of explosive events in 1815. Ultimately, it led to a climate downturn that was famous for the year without a summer in 1816. This is an event that was seen throughout the civilized world, a devastating event. It led to social reforms in Europe. Poor people begging on the streets became common. Mary Shelley was hiding from the bad weather in Lake Geneva, Switzerland, and wrote the novel Frankenstein as a result of this eruption. Not knowing about the eruption per se, but knowing about the cold, inclement weather that kept them inside. And there's a morose, cold clamminess to the novel if you read it. Krakatoa, one of the big ones, occurred on August 27th, 1883, and this is known as a phreatic eruption. It's believed that seawater seeped into the magma chamber, became superheated, and the explosion that resulted was heard nearly 5,000 kilometers away by a lifeguard in Perth, Australia, and by some locals in Sri Lanka on the other side of the Indian Ocean. So a very loud eruption, very spectacular eruption, killed over 36,000 people almost instantaneously from the gases, the ash, and the tsunamis. The global temperature dropped by almost 2 degrees in the next year. It took about 5 years to recover. Finally, we got over the Krakatoa slump in 1888. There were numerous reports of skeletons found floating on volcanic pumice, so that fluffy, frothy, glassy volcanic material that floats. People were found floating on top of this floating rock on the east coast of Africa a year after the eruption. This is Krakatoa today. You can see that most of the island was destroyed. The volcano was about 3,000 feet tall, about 1,000 meters high when it erupted, and we were left with almost nothing. Since then, Anak Krakatoa, the child of Krakatoa, has been rising from the old crater. So Krakatoa is active. It will go off again. Maybe it'll be just as big and bad as the last time. Closer to home in the Americas, we're going to take a cruise down from the Bahamas, past Puerto Rico, to the island of Martinique. The capital of Martinique, Saint-Pierre, was completely destroyed in May of 1902. And at the time, the population was around 28,000. Many of the other islanders from surrounding towns and villages came to Saint-Pierre because of their fear of this volcano. It was known to the local Carib Indians as the Fire Mountain. So what happened here? A glowing cloud burst out of this mountain and shot down at 100 miles an hour into Saint-Pierre, incinerating the town. Fortunately, it's all been rebuilt, setting the stage for the next one. During this eruption, the volcano generated what's called a nuée ardente, which is French for a cloud that glows. It's a very destructive, very fast-moving, glowing or incandescent mass of gas-enveloped particles. Now, this is associated generally with certain types of very explosive volcanic eruptions. Here we see a nuée ardente being generated by a volcano, and like an air hockey game, this material slides on a cushion of air. So it's able to reach speeds of 100 or more miles an hour going down slope because it's not actually touching the ground. It's floating on a cushion or a slide of air. The result was almost everyone was killed almost instantaneously. The traditional legend was only one person survived. It was this guy who is a prisoner in a really bad prison in Saint-Pierre, believed that he was imprisoned for being in a bar fight the night before, or maybe he killed someone. Nobody knows because the records were destroyed. But fortunately for him, he was put in a terrible cell deep in the prison, and that allowed him to survive with only severe burns. There were a few other people that survived, at least for a few hours or a few days. Only a handful of people ultimately lived through this event. So this cloud of superheated steam and volcanic gases and dust had a temperature that was believed to be around 1,075 degrees centigrade, which translates to around 1,900 degrees Fahrenheit, close to what you see here. In Ruiz, Colombia, in 1985, an eruption generated a lahar that killed 23,000 people. They were buried below this volcano by the hot mud of the lahar. Overall, when we look at causes of fatalities related to volcanism, we can see that quite a few are unknown deaths, most likely a mixture of things. Lightning does kill people. earthquakes, floods, debris avalanches. That can be a big one. Gas emissions, in the case of a Nieuwe Aardon, that's a problem. Lava flows, usually people get out of the way. Tsunamis, this is a big one. Just like in earthquakes, tsunamis are one of the big killers. Indirect effects include famine, and this is something we're still getting a handle on globally. Lahars, we have indirect effects of lahars, famine perhaps, contamination of water supplies, and direct effects where people are buried in mud. Pyroclastic flows, hot particles. Again, this could be a component of a Nieuwe Aardon or separate. And then ashfall. Ash can bury a house, a building, and then when that building collapses, it results in death. Another curious way that a volcano can get to you occurred in Lake Nyos in Cameroon. This was a real mystery in 1986 that 1,749 people and 3,500 cattle were killed mysteriously overnight. Investigations revealed no poisonous gases. People simply went to sleep and never woke up again. And what ultimately was determined to be the cause was an enormous amount of CO2 built up in this stratified lake. It means the lake never overturns like lakes overturn here in Canada. So the CO2 built up like a hot can of Coke, and once there was an earthquake, a landslide knocked a little bit of this cliff off here that destabilized the column in the lake, causing the water to overturn. Once this water began to overturn, the CO2 charged water at the bottom of the lake became effervescent. That's the banging of a can on a table and then opening it up kind of effect. And the result was a bunch of CO2 was burped out of this lake. CO2, being heavier than most air molecules, rolls down the valleys. So this explains why cattle and people living in the valleys were killed, whereas people that lived 10 or 20 feet higher up on a slope just woke up in the morning like nothing happened. So it's believed that 300,000 to 1.6 million tons of CO2 was released. One of the guys on my PhD committee was George Kling, a biologist at the University of Michigan, and he worked along with Yoshua Zhang, another guy on my committee, to develop this structure that they put in the lake. So we have a floating, kind of a pontoon station at the top of the lake and a pump at the bottom. And what they do is they pump up through the central tube, and this draws CO2 out of the deep water and vents it safely at the surface, hopefully preventing a buildup of CO2 gas that's going to result in another fatal event. So putting all that together in this diagram of death, you might say, we have a volcano with prevailing wind moving in this direction. An eruption column is going to perhaps generate an eruption cloud. If this gets high enough into the atmosphere, it's going to stay there for years. Nonetheless, the wind is going to take it away, depositing ash and pyroclasts in dominantly this direction. Bombs will fall nearby, becoming part of the slope. Pyroclastic flows will add to these bombs and building up the slope. Landslides and debris flows will move material down the slope. Fumaroles will provide gases and conduits for hot water. Acid rain results from the ash and sulfur dioxide in the atmosphere mixing with water and then falling. We may have the development of a lava dome, a bulge in the side of the volcano, as in Mount St. Helens. When that collapse occurs, we end up with a lateral explosion blasting out to the side. Any water that's on this volcano, whether it's in the form of a summit glacier or just snow deposits, can result in these deadly lahars. Now, places like Tacoma, Washington, parts of Seattle are built on old mud and lava flows. What does this tell you as a geologist now? If you're building on a lava flow, that means lava flowed there, which also means, hopefully now, that it's likely lava will flow there again. So you're building in the worst possible place, oftentimes. That's just the way people are. Now, potentially dangerous volcanoes on the West Coast include those of Alaska. These have all been active in the last 300 years. In Hawaii, all active even to this day in the case of Kilauea. Along the West Coast further to the south, we see a series of volcanoes, probably more than you thought were there, some of which have been active recently, including Mount Baker, Mount Rainier, Mount St. Helens, Mount Hood, Shasta, Lassen, the Mono Inyo craters, which you can see in action today. There's some really weird biological stuff going on in here. And then you see other volcanoes that haven't been active in the last 1,000 years, but could still go off. And then a few that we don't understand very well, that we don't understand very well. So this brings us to some positives. Geothermal energy. This is a picture from California, from your book. We can use this geothermal energy, this hot material near the Earth's surface, to make steam. Steam is then used to generate electricity via turbines, just like a big steam engine, except in this case, no coal or wood is required. In Iceland, I took these photos of a geothermal plant that is, or at the time was currently expanding. So you notice very characteristic cooling towers or heat exchangers in the geothermal facilities. You can see it's a pretty extensive network of pipes. Now, if you go to Iceland and you use tap water, there's always two taps for whatever reason, I don't understand. One of them comes right out of the mantle. It is really hot water and it smells like sulfur. Your cold water comes right out of a glacier, apparently. So you have incredibly cold water right next to incredibly hot water, making for an interesting face washing experience. Now, they were drilling at the time to establish a new exchanger, and they hit a gas pocket and it blew up. So this is where they were drilling. The rig was sitting somewhere here. The rig was blown 2 to 3 kilometers away, and somehow the people working on the rig weren't killed. But the result was they blew a big hole in the ground, their rig was blown away and destroyed, and this part of the project was abandoned. What might be the effects on civilization of a Yellowstone-type caldera eruption, such as the one described at the beginning of this chapter? One word: devastation. It will devastate civilization. It will destroy much of North America, taking down the global economy, taking down the global food chain. It's going to be a big problem. So yes, Yellowstone Park is going to destroy the world as we know it, but it's not all bad. Before it destroys civilization, it may provide us all with cheeseburgers, corn dogs, chicken McNuggets, or Burger King McNuggets, whatever they're called. These are all possible because microbes that were recovered from hot springs in Yellowstone Park have been trained to produce meat, or at least meat-like substances. And one way to get things done in the world is get 2 of the richest people in the world to pay for it. So Jeff Bezos of Amazon and Bill Gates of Microsoft have agreed to support this venture, and we'll see what happens. Looks like an interesting story so far.